How does output impedance impact amplifier design? Imagine trying to pour water into a narrow pipe versus a wide one. The flow changes based on the pipe's size. In amplifiers, the output impedance acts like that pipe, influencing how well the amplifier can deliver signals. Output impedance is the measure of how much an amplifier resists current flow from its output. It is expressed in ohms. A low output impedance means the amplifier can push more current into the load without losing voltage. This is important because it helps the amplifier deliver clear signals without distortion. When designing an amplifier, matching the output impedance to the load's input impedance is key. If the impedance is too high, the signal can drop or become distorted before reaching the device it drives. For example, in audio systems, speakers typically have an impedance of 2, 4, or 8 ohms. The amplifier's output impedance should be very low to send power efficiently to these speakers. The damping factor is a term used in audio amplifier design. It is the ratio of the load impedance to the amplifier's output impedance. A higher damping factor means the amplifier has better control over the speaker's movement. This results in clearer sound with less unwanted oscillation or ringing. Modern amplifiers often have output stages that change impedance depending on the frequency. This can cause issues with stability when driving capacitive loads, which are common in electronic circuits. If the output impedance isn't managed properly, it can lead to oscillations or even damage. In some cases, the output impedance affects how much gain the amplifier can provide. When designing 4 different loads, engineers might adjust the gain to keep the output stable and the signal quality high. Choosing the right components, like transistors or operational amplifiers, is also important because their output impedance characteristics vary. Ensuring the amplifier remains stable involves understanding how the output impedance behaves at different frequencies. Sometimes, adding small compensation components helps keep the circuit steady. This is especially important when working with complex loads or high-frequency signals. In summary, output impedance is a vital part of amplifier design. It influences how well the amplifier can deliver power, how stable it remains, and how accurately it reproduces signals. Managing this parameter carefully helps create reliable, high-quality amplifiers for all kinds of electronic applications.